dear students. Today we are going to discuss new point in a physical pharmaceutics one. So in previous lecture, we have discussed the basics about the gas state, and now next point is a in a physical pharmaceutics is a liquefaction of gases. So subject is physical pharmaceutics. In first lecture, video lecture, we have discussed the basic difference between solid, liquid, and gas, and the gas laws along with ideal gas equation. Now next, which is very much important point, sometime question asked in the semester examination, that is liquefaction of gases. So we will see what is mean by liquefaction of gas and how the liquefaction is carried out. It is based on the which concept. So liquefaction of gas, as the name suggests, liquefaction. So liquefaction of the gas means conversion of gas to liquid. So gas is converted into liquid through the process. This process is known as liquefaction. The conversion of gas to liquid is known as liquefaction. So already we have discussed how solid, liquid, and gas are converted into each other. So in this process, what will happen? In this process, what we do? We do conversion of gas to liquid. So gas molecules are converted into liquid molecule through the process known as liquefaction. Now, how liquefaction is carried out? By considering which parameters that we'll discuss. So liquefaction of the gas is carried out by considering pressure and temperature. So first of all, what we'll do, we will just see we'll revise the characteristics of gas and liquid, because we have to convert gas to liquid. So first of all, we must know the certain characteristics of the gas molecules and liquid molecules. Then only we can better way understand the conversion of gas to liquid means exactly what you have to do. In case of gas, already we have discussed in first video lecture, gas molecules are wide apart from each other. These are widely distributed. Why? Because they have very negligible intermolecular force of attraction and high kinetic energy in comparison to the liquid. Similarly, if you see in case of liquid molecules are close to each other. These molecules can slide over each other. If you see the distance between the two liquid molecules, it is very much less compared to gas. Gas molecules are wide apart from each other. You can see in the diagram. So if you compare the distance between the two molecules in case of gas and liquid, in case of gas distance is more, whereas in case of liquid distance is very much less. Then if you see the kinetic energy, gas molecules are highly energetic molecules, and that's why these are continuously in motion. So that's why kinetic energy of gas molecules is more. These molecules are continuously moving, whereas in case of liquid, kinetic energy is less. Next important thing, we have compare the gas and liquid with respect to the distance and kinetic energy. The next important point with respect to the gas and liquid, that is volume occupied by gas molecule, volume occupied by the liquid molecule. So if you take the fixed weight of the gas and fixed weight of liquid, and if you compare the volume, the gas occupy more volume because they are wide apart from each other, whereas liquid occupy less volume. So conversion of gas to liquid means, in short, what we have to do, we have to convert the molecules which have more distance to the molecules which are less distance. We have to convert the molecules which have more kinetic energy to the molecules which have less kinetic energy, like this. And in short, what you have to do, we have to reduce the volume. Initially the volume is more, and next we have to volume is less. So comparing these three parameters, we can better way understand conversion of gas to liquid means what. Conversion of gas to liquid means, in short, the reducing the distance between the two molecules, reducing the kinetic energy, and reducing the volume. Means volume must be reduced, the kinetic energy must be reduced, and next is distance. So volume, kinetic energy, and distance between the molecules must be reduced, then only the gas can convert into liquid. So in short, what happens, we'll see, the gas is converted into liquid. Gas is converted into liquid means, in short, what we have to do, in short, just we have to convert the molecules which are wide apart from each other to the molecules which are close to each other, like this. Means by reducing volume occupied by the molecule, by reducing the energy. And volume, how volume is reduced? By reducing the distance between the molecules. So these three parameters we have to consider. Now, why liquefaction of gas is important? Liquefaction of the gas, this liquefaction concept is applicable in the formulation of aerosols, and that's why liquefaction of gas is important. In your syllabus the aerosol has mentioned, but the liquefaction has not mentioned. So for formulation of aerosol, the liquefaction concept is very much important, and that's why you must know what is meant by liquefaction. Liquefaction of gases means simply a conversion of gas to liquid, and that we can carry it out by reducing volume, by reducing energy, and by reducing the distance between the molecules. Now these parameters we have better way understood. Means in short, we have to reduce the volume, we have to reduce the energy, and we have to reduce the distance. How we can carry it out? So volume you can reduce by applying the knowledge of the laws which we have discussed in first lecture, Boyle's law and Charles law. So according to Boyle's law, volume occupied by the gas is inversely sorry according to Boyle's law, volume occupied by the gas is inversely proportional to pressure, and according to Charles' law, volume occupied by the gas is directly proportional to its temperature. Now, we have to convert gas to liquid. Means in short, what we have to do? We have to reduce the volume of the molecules. So how you can reduce the volume? Here, volume is inversely proportional to pressure. In order to reduce the volume, you must increase pressure. If you increase the pressure, then automatically volume will reduce. And according to Charles' law, in order to reduce the volume, because volume is directly proportional to temperature, so in order to reduce the volume, the temperature must be reduced. So these two important parameters we have to consider. Means what we understood. See how we have linked the points with each other. Initially we have discussed how conversion of gas to liquid, which parameters we have to reduce, and later on how you can reduce this parameter. The first important thing by applying pressure, and second by reducing temperature. So gas molecules are converted into liquid molecules. How? Gas you can convert to liquid by applying pressure on the gas and simultaneously by reducing temperature. So just reduce the temperature of the gas and simultaneously apply the pressure on the gas molecule. Automatically what will happen? The gas converted into liquid according to Boyle's law and Charles' law. So what will happen? If I have gas molecules like this, which are widely distributed, wide apart from each other, these are gas molecules. Now suppose if you apply the pressure on these molecules, if you apply the pressure from top, what will happen? These molecules come close to each other. These molecules come close to each other. So as you apply the pressure, what will happen? Sorry, here. As you apply the pressure, as you increase the pressure, what will happen? The molecules come close to each other. The first important thing. So pressure increase. As pressure is increased, what will happen? The volume is reduced. The volume we can reduce. Conversion of gas to liquid means what we have to do? We have to reduce the volume by applying pressure. And what is the rule of temperature? If we reduce the temperature, what will happen? According to Charles' law, volume also reduce. And in addition to this, on reducing temperature, what will happen? Gas lose its, if we reduce the temperature, what will happen? Gas lose its kinetic energy. So in short, we are removing the energy from the molecules. How we can remove the energy from the molecules? By reducing temperature. So if you increase the temperature, sorry, if you increase the pressure, molecules come close to each other, means distance between the molecules reduce. And if you decrease the temperature, what will happen? If you increase the pressure, the distance between molecule reduce, and if you decrease the temperature, then what will happen? The gas lose its kinetic energy and gas converted into liquid. This is how the conversion of gas to liquid takes place. The gas molecules can convert into liquid molecules by two important things. First, by increasing pressure, molecules come close to each other, and second, by reducing temperature. If we reduce the temperature of molecules, what will happen? Gas lose its kinetic energy, means more kinetic energy molecules, highly energetic molecules convert into less energetic molecules. So by applying pressure and by reducing temperature, you can convert gas to liquid. So far we have discussed the introductory part. Now one thing, it has already clear that we have to apply the pressure on the gas, and second thing, we have to reduce the temperature of the gas molecules. So how you can apply the pressure and how you can reduce the temperature, how much pressure we have to apply and how much temperature. So how much pressure means what is the exact value of pressure, how much pressure and how much temperature, how much pressure we have to apply, what is the exact value with respect to the atmospheric pressure, and how much temperature in terms of degrees Celsius or in Kelvin. So these values required for conversion of gas to liquid are different for different gases. Suppose the temperature pressure condition required for liquefaction of carbon dioxide. So for carbon dioxide liquefaction, suppose we have to convert the carbon dioxide gas, CO2 gas, to carbon dioxide liquid, how much pressure is required? The temperature is 304 Kelvin and pressure is 72.9 atmospheric pressure. So we have to reduce the temperature, we have to set the temperature which is equal to 304 Kelvin, and the pressure we have to apply which is equal to 72.9 atmospheric pressure. Automatically carbon dioxide gas convert into liquid carbon dioxide. So these are the values of the pressure. Now these values required for conversion of gas to liquid are different for that of helium, for nitrogen. So each gas has its own critical pressure and critical temperature.